We're supposed to find the horizontal and vertical components of a helicopter traveling 95 kilometers per hour at an angle of 35 degrees to the ground. So, draw a picture first. Here's the ground, 35 degrees to the ground. So, think about another line. We're just going to rotate up from the ground 35 degrees. It'll be something like this. 95 kilometers per hour. So that's the motion. It's like a plane, maybe that's a helicopter that's maybe lifting off and it's kind of going forward and up at the same time. We're going to know the vertical and horizontal components. This is often the first step in a two-dimensional problem. They give you some initial velocity at an angle, and you have to break it into horizontal or x components and y components. Okay, so part of that arrow, that 95 kilometers per hour, is being shared. It's not all going up. You're not going up at 95 kilometers per hour, and you're not going out at 95 kilometers per hour. You're sharing. So let's find the x component of that velocity. That is going to be, so this is the adjacent side, so we'll be dealing with cosine 95 cosine of 35. And that would be 77.8, or I'll make two significant digits, 78 kilometers per hour. That's the horizontal component. What about the vertical component? Okay, that would be this piece right here. It is opposite to that angle, so we use sine. You get 54.48, which I'll just round to 54. Two significant digits, kilometers per hour. Right? That's all there is to that one. It's a quick problem, just meant to help you, look into a two-dimensional problem at the very beginning. This is your first step. You find an x velocity and a y velocity components of the original velocity. Okay, so just always remember to break that down. That's your first step. Here's another fun question. How fast must a truck travel to stay beneath an airplane that is moving 135 kilometers per hour at an angle of 27 degrees to the ground? Okay, so here's the ground. Maybe here is the plane. Beautiful plane, huh? And it's flying. I guess it's not flying horizontal. I should have drawn it at an angle. Boo. Okay. Here's the line parallel to the ground. It's flying at an angle of 27 degrees at 135 kilometers per hour. Okay. So once again, that velocity is being shared. It's not all horizontal, okay? Which means if we are in a car on the ground, we don't have to travel at 135 kilometers per hour because our velocity doesn't have to be shared. It's going to all be horizontal. We just need to know what component of the plane's velocity is horizontal, Vx. So that would be 135 cosine 27. The car's velocity needs to be 135 cosine 27, 120.3, or just 120 kilometers per hour. Alright. Do one more in this video. So these are pretty quick. Truck drives up a hill with an incline of 15 degrees. If the truck has a constant speed of 22 meters per second, what are the horizontal and vertical components of its velocity? Okay. 22 meters per second. The angle here is 15 degrees. We want to know horizontal and vertical components. We'll do the horizontal in red. The x velocity component would be 22 times its adjacent, so cosine of 15, and that's going to be some number. I'm not going to calculate it. The y velocity, 22 sine of 15. And that's how we start a lot of our problems when they're two-dimensional motion.